Bismillahirrahmanirrahim. Hello students, welcome to another video. This is Hamza Noor from Aero Education Network, and in this video I'm going to solve some more past paper questions for the topic Vectors in Mechanics for International A-Level Edexcel M1 Mechanics. And in my earlier video I discussed question number 3 and question number 4 of the handout. Here I am with question number 5 first, which is GCE M1 January 2012, and the question is question number 7. So the question says that a boat P is moving with constant velocity minus 4I plus 8J kilometer per hour. The requirement of part A is to calculate the speed of boat P. So we are going to find the magnitude of this velocity vector. Okay. In order to find the speed, you need to find the magnitude of the velocity vector. So this is the basic concept. So for part A, the magnitude of the velocity vector would be under root of minus 4 whole squared plus 8 squared. So this is under root of 16 plus 64, which is under root of 80, and correct to three significant figures 8.94 kilometer per hour. Since the velocity vector is also given to you in kilometer per hour, so the speed is also kilometer per hour. All right, so this was the requirement of part A. After this, we have part B. When t is equal to 0, the boat P has position vector 2I minus 8j kilometer. Okay, so this is basically the initial position vector of boat P, R naught vector. At time t hours, the position vector of boat P is a small p kilometer. We need to write down the vector of a small p in terms of t. So as simple as that, we are going to use the equation R is equals to R naught plus Vt. Okay, and specifically, the R vector is called the small p vector. Okay, so in place of R, I'm going to write p, and R is equals to R naught plus Vt. Let me make this subscript 0 a little perfect. So R is equals to R naught plus Vt. So in place of R, we are going to write P. So the initial position vector is 2I minus 8j. Okay. And the constant velocity vector is given to you in the question, which is minus 4I plus 8j multiplied by t. So if you leave your answer in this form, this is also perfectly fine. But as you know that a usual practice is to identify the coefficient of I and coefficient of j in terms of t, which is quite helpful for the upcoming parts. So what you can do is you can take I common, multiplied by 2 minus 40, okay, and then taking j as common, multiplied by minus 8 plus 8t. Okay, so you leave your answer in this form. It's highly recommended to do so because in the further parts you would need this particular form. Okay, where you have identified the coefficient of I and the coefficient of j. So I component is 2 minus 40 and j component is minus 8 plus 8t. So now let's move on to the next part. So for part C and D, I'll bring the picture of the question over here. Okay, and we are going to focus on part C and D only. All right. So it says that a second boat Q, okay, we have another boat which is Q. It is also moving with constant velocity. At time t hours, the position vector of Q is a small q kilometer, where the Q vector, meaning the position vector of boat Q, is given to you 18I plus 12j minus t times 6I plus 8j. So the requirement of part C is to find the value of t when particle P is due west of Q. Okay, so due west means that horizontally towards left. Due west of Q, this means that if boat Q is over here, so boat P is basically horizontally towards the left, due west. Okay, since you know the compass, north, south, east, and west. East is on the right and west is on the left. Okay, So if you make a north at boat Q, so boat P is basically due west of boat Q. So now what we know the fact is that, you know, in the previous part, we have found the position vector of boat P, which is 2 minus 4t into I plus minus 8 plus 8t into j. Okay, so I can say that, the coordinates of boat P at any value of t are 2 minus 4t comma, as we know that j component is minus 8 plus 8t, so minus 8 plus 8t. Okay, so you just consider this as coordinates, the I and j components respectively. And for board Q, I'm also going to do the same thing. I'm going to, identify the coefficient of I and the coefficient of j. So I can say that taking I as common, multiplied by 18 minus 60, okay, and taking j as common, multiplied by 12 minus 80. Okay, so therefore I can say that the coordinates of board Q at any value of t are 18 minus 6t comma 12 minus 80. Okay, so this is the thing. Now, as we have seen in the previous questions that, in the previous parts, the displacement vector PQ is asked or QP vector is asked. So we can use that thing as well. But here in the previous parts, you were not required to find the PQ vector or the QP vector. Okay, so as you only know the position vector of Q and the position vector of P. So what we can do over here is that since the boat P is due west of boat Q, so this means that, the J components of both the boats will be equal. This makes sense or not? Because, this PQ would be a horizontal line. It is exactly the same thing as saying that, PQ is a horizontal line. Boat P is over here and boat Q is over here. Okay, so the x coordinates will be different, meaning the I components will be different, but the j components will be the same. So therefore, I can explicitly mention this thing that j components of both of the boats are equal. So here is basically one way to do this. The other way is that either you can find the displacement vector, or you can say the direction vector of QP or the vector PQ according to vector subtraction law. Okay, once you find that vector, and in that vector PQ or QP, you just equate the j component with 0. Okay, that is basically the whole concept. But since here the vector PQ or vector QP was not asked, so I'm not doing it with that approach. I'm just, considering the position vectors of both P and both Q respectively. So when boat P is due west of boat Q, so it is horizontally towards the left of Q, means on an axis, they are on a same horizontal line. Okay, so the J components will be equal to each other. So therefore I can say that J components of P and Q will be equal. Okay, so I'm just going to equate this minus 8 plus 8t with 12 minus 8t. Okay, so 8t plus 8t is equals to 12 plus 8, meaning 16t is equals to 20, and therefore t is equals to 20 divided by 16. So the value of t is 5 over 4. This is the requirement of part C. As simple as that. All right, this makes sense. Okay, so we have just equated the j components with each other and we have found the value of t. So this was the requirement of part C. So now let's move on to the next part. So I'll bring the picture on the next page for attempting part D. Okay. So in part D, what we need to do, we need to find the distance between P and Q when boat P is due west of Q. Okay, what we know the fact is that when boat P is due west of boat Q, the value of T is 5 over 4, which we have found in part C. So what we are going to do, we are going to use this value of T. Okay, so what you know the fact is that I'll just bring the sketch over here, the screenshot on the next page. I'm just going to put the value of T in both of these vectors individually, and I would be easily able to find the coordinates in the form of I and j. And what we know the fact is that the j components of both boards will be equal. So we just need to find the horizontal distance. Okay, we just need to find the change in x coordinates, meaning the change in I components only. Okay, so this is basically the concept. So all you need to do is just substitute the value of t into the I components, and that would be enough. Okay, because finding the j components is not required, as you know that PQ is a horizontal line. So just change in the I components would be enough, and it will give you the answer. So 2 minus 4 times 5 over 4 and 18 minus 6 times 5 over 4. So just evaluate these values. So 2 minus 5 will give you minus 3, and 18 minus 6 times 5 over 4, this will give you 10.5. Okay, so this means that if you consider axis, let's say x-axis and the y-axis, so basically the x coordinate of both q is positive, okay, and the x coordinate of both p is negative. Okay, so P is basically the x coordinate is minus 3, and for both Q the x coordinate is 10.5. Okay, so we just need to find the distance. So we just need to find this distance of the horizontal line. Okay, and which is simply distance, you can find it in this way, that change in x coordinates. So 10.5 minus minus 3, meaning 10.5 plus 3. Okay, 10.5 plus 3, which is supposed to be 13.5 kilometer. This is supposed to be your answer. As simple as that. Nothing else. Okay. Or it is exactly the same thing as saying, finding the distance between P and Q. So magnitude of the vector PQ, or you can say magnitude of the vector QP. Okay. So we have found the distance over here. So this was basically the requirement of part D. All right. So finding the j components is not necessary, okay, because P and Q both are on the same horizontal line. All right. If they were not, so you would have to find the j component as well, and then you would find the magnitude of the vector. Okay. So that is the thing. So this was basically the question number 5 of the handout, which is GCE M1 January 2012, question number 7. So now let's move on to the next question. So up next is question number 13 of the handout. Okay, and this is IAL M1 June 2015, question number 7. So let's have a look at this question. It says that a particle P moves from point A to point B with constant acceleration Ci plus dj meter per second square, where C and D are positive constants. And the velocity of particle P at point A is minus 3I minus 3j meter per second, and the velocity of particle at point B is 2I plus 9j meter per second. The magnitude of the acceleration of the particle is 2.6 meter per second square. Find the value of C and the value of D. Okay, so first thing first, what we know the fact is that there is some acceleration, and we have a journey from point A to point B, and we know the velocity vectors at point A and point B respectively. Okay, so if I consider the initial point as the point A, so at that time t would be equal to 0. So at point A, I can say that, the velocity vector is basically the initial velocity vector, and at point B, it is the final velocity vector. So simply we are going to use this equation, v is equals to u plus at. Okay, and the final velocity vector, meaning at B, the velocity vector is basically 2i plus 9j. Okay, and the initial velocity vector, which is at point A, this is minus 3i minus 3j, and the acceleration vector is ci plus dj and multiplied by t. Okay, we are considering the path from point A to point B. All right. So what we need to do, we need to find the value of C and the value of D over here. So first of all, what I can do is I can basically simplify the vector, meaning I can say that 2i plus 3i plus 9j plus 3j, this is equals to ci plus dj into t. Okay, so therefore I can say that this becomes 5i plus 12j is equals to ci plus dj completely multiplied by t. All right. So as you know that t is basically a scalar quantity, right? Time is a scalar. So this t can be treated as a scalar multiple. Okay. So if anyone sees this equation, they would say that, this vector 5i plus 12j is a scalar multiple of this vector ci plus dj, isn't it? When one vector is a scalar multiple of another vector, a concept which you are studying since O-level IGCSE mathematics. You know, let's say one vector is AB and the other vector is CD. Let's say one vector is AB, other one is CD. So if I say that AB vector is a scalar multiple of CD vector, so this essentially means that the magnitude of AB vector is equals to K times the magnitude of CD vector. Make sense or not? This is the basic concept which you are studying since O-level mathematics. Okay, so therefore I can say that the magnitude of 5i plus 12j is equal to the magnitude of ci plus dj multiplied by t. As simple as that. Okay, so the magnitude of 5i plus 12j will be under root of 5 square plus 12 square, and ci plus dj is basically the acceleration vector, and the magnitude of acceleration is given to us in the question, which is 2.6. So this is equals to 2.6 multiplied by t. As simple as that. Just solve this equation and find the value of t. Okay, so under root of 25 plus 144 is equals to 2.6 t. Okay, so this is under root of 169, which is 13. Okay, so under root of 169 is equals to 2.6 t. Therefore, t is equals to 13 divided by 2.6. So what is the value of t? 13 divided by 2.6, the value of t is equals to 5. So what we have done, we have successfully found the value of t over here, which is 5. Okay, so as we know that we need to find the value of C and the value of D. So I can say that, I can simply just use this equation over here. Okay. And therefore I can say that, Ci plus dj multiplied by 5 is equals to 5i plus 12j. We just need to compare the vectors now. So I can say that Ci plus dj is equals to 5i divided by 5 plus 12j divided by 5. So ci plus dj is equals to I plus 2.4j, and therefore we can say that c is equals to 1 and d is equals to 2.4. This is supposed to be your answer. All right. So this was basically an approach for this question. We have an alternative approach as well. I mean, the approach is quite similar. However, the technique is something other. So I hope you have copied down this working. So I'll move on the next page for the alternative working. I mean the alternative approach, which I want to explain over here. Okay. So I'll bring the picture of the question on the next page. Okay. So this is basically like an alternative approach. All right. So what we know the fact is that, what we established, what we established earlier that 5i plus 12j is equals to ci plus dj multiplied by t. And what we know the fact is that the magnitude of acceleration is equal to 2.6 meter per second square. Okay, so after this, a technique is, something else. So just listen to it carefully. What we know the fact is that t is a scalar uh, quantity, right? Which is treated as a scalar multiple. However, if I want to use another scalar multiple, let's say k, okay, because when we say, when we are dealing with especially the vectors which are parallel, when we say that one vector is parallel to another, we say that one vector is k times of another vector. Or when we say uh, one vector is moving in the direction of a particular vector, I mean, one vector is moving in a direction of another vector. So we say that one vector is a scalar multiple of another vector. So usually we introduce a scalar parameter k over here, right? All right. So in order to deal with a similar approach, if you want to introduce a scalar multiple k over here, so what you can do over here is that you can simply say that ci plus dj is equals to 1 upon t is completely multiplied by 5i plus 12j. Okay. And now I can replace this 1 upon t with a scalar multiple k, with a constant k. As we know that, t is also acting as a scalar multiple. So 1 upon t would also be acting as a scalar multiple. So I can simply say that ci plus dj is equals to k is completely multiplied by 5i plus 12j, where I will say that k is equals to 1 upon t. This makes sense to you or not? I can say that ci plus dj is a scalar multiple of 5i plus 12j. All right. And now what we can say that the magnitude of ci plus dj is equals to k times the magnitude of 5i plus 12j, and the magnitude of the acceleration vector is given to us 2.6, where the acceleration vector is itself ci plus dj. So 2.6 is equals to k times the magnitude of this 5i plus 12j vector. So k times under root of 5 square plus 12 square. So 2.6 is equals to k times under root of 169. So k is equals to 2.6 divided by 13. So 2.6 divided by 13 is 1 upon 5, meaning k is equals to 0.2. Now we can use this value of k. And as we know that t will come exactly 5 as we have previously established. So zero point 0.2 will be equals to 1 upon t, because k is equals to 1 upon t. So t is equals to 1 divided by 0 0.2. So t is equals to 5. So in this way, I mean, in this approach, in this particular approach, finding the value of t would not be compulsory. But if it was asked, so t is equals to 5, obviously. So we have identified that k is 0 0.2. All right. So now I can mention this thing that ci plus dj is equals to 0.2 is completely multiplied by 5i plus 12j. So 5 times 0.2 is 1. So this is I plus 2.4j. This is the vector ci plus dj which we are looking for. Therefore, c is equals to 1 and d is equals to 2.4. This is supposed to be your answer. Okay, so this technique is also quite helpful. Okay, so what I did, I just sent this t over here on the left and I replaced this 1 upon t with a scalar multiple k. Alright, so you must be familiar with all of the approaches in which you can deal the questions. Whatever clicks your mind immediately at the very first instant, just attempt it and move forwards, move ahead in your paper. Alright, so for the sake of this video, I've discussed two questions. This was question number 13, IAL M1 June 2015, question number 7. And the previous one was question number 5, which is GCE M1 January 2012, question number 7. So inshallah, I'll see you in my next video. So stay tuned to my channel. This was the working for part A of question 5 and part B. And here I just mentioned part C. Okay. And this was part D. Okay. So inshallah, I'll upload more videos. So stay tuned to my channel. Thanks for watching. Assalamu alaikum.